Next, let's graph the function f of xy equals the square root of 4 minus x squared minus y squared. Now, this is not linear because there's exponents on the variables and they're inside a square root. Now, lest you make the mistake of thinking that the squaring and the square rooting will cancel each other out, let me just remind you that the square root of a plus b is not equal to the square root of a plus the square root of b. So I can't say square root of x squared is x and square root of y squared is y. Now, if you're thinking, oh, I thought we could do individual square roots, that's only if you're multiplying. In other words, you can take the square root of each factor. But if you're adding or subtracting, so you have terms, you can't take the square roots of them individually. So with that said, let's look at this. We have z equals 4 minus x squared minus y squared. Well, one thing we are allowed to do is to square both sides of an equation. And that will give us z squared equals 4 minus x squared minus y squared. And that's starting to look familiar to me because when I see x, y, and z all being squared, I'm thinking maybe that's a sphere. In fact, let's add x squared and y squared to both sides of the equation, and that will give us x squared plus y squared plus z squared equals 4. And as we saw in section 8.1, that is the equation of a sphere. It's a sphere centered at the origin with radius 2, because 4, of course, is 2 squared. So there we go. That's all we need to graph this. Got a sphere. Centered at the origin. And it has radius 2, so it's going out to 2 there. It's intersecting the x-axis at 2 there, and the z-axis at 2 there. Now, the only thing is, notice that in our original equation here, z equals square root of 4 minus x squared minus y squared, that z has to be positive, right? Because the output of a square root is always positive. That's how we define the square root symbol. So I am actually going to need to erase some of this stuff here because we actually only want the part of the sphere that's above the xy plane, because that's where the z's are positive. If you're below the xy plane, your z's are negative. But anyway, there we go. That's the graph of that. The next example asks us to sketch the graph of the function f of xy equals x squared plus y squared. In other words, z equals x squared plus y squared. This is not a sphere because the z is not squared. In fact, this is nothing we've ever run into before. So it's not one of the kind of special things that we did in the last two examples. So what was special about the last example was that we could easily see, or turn it into, I should say, the equation of a sphere. And the one before that was special because it was linear. This one is not linear and it's not a sphere. It's not linear because there are squares, exponents on the x and y variables, and it's not a sphere. In fact, it's, like I said, it's nothing that we've run into before. So how to draw that? Honestly, we don't have the tools for drawing this right now. We need something called level curves, and I'll tell you about those in the next video.